That is, what if an object gets trapped in an already curling field of water? Does the object now start moving in a closed loop due to the curl? So is it that an already existing curl within a fluid can be the cause of making objects in the fluid go round and round? Further, in this video, see if the Stokes theorem works only for fluids. I mean, what if you are stirring a powdered material instead of soup, like salt, for example? So what if you start stirring salt? Will it still cause a curl within itself? So does Stokes' theorem work only for fluids or vector fields? Or are there exceptional cases when they work for powdered solids also? Keep watching this video till the end to get these answers at visualizing math and physics.
Expansions of series, like Taylor's series, Maclaurin's series, etc., which, graphically speaking, tend to go to touch infinity, hence the name asymptotic. Also, he, along with another scientist, named Felix Hoppe Seyler, discovered that oxygen is carried in the bloodstream by hemoglobin and that blood changes its color as you aerate the hemoglobin solutions. Now that a legacy of scientific contributions. In this video, we shall learn about George Stokes' theorem on fluid mechanics, specifically on vector fields. Stokes' theorem, in layman's words, states that stirring a fluid along a closed loop causes a curl or a spinning pattern within the fluid. So, whenever you stir your soup or your coffee with a spoon, the particles of the liquid interact with each other in such a fashion so as to create a curl. The closed integral sign that you are seeing here means that you are not stirring linearly, and instead you are stirring in a closed loop pattern of motion. This closed loop can be, say, stirring in a triangular pattern with the spoon in the coffee, or, say, stirring in a square pattern, or, say, stirring in a hexagonal pattern, etc. As long as your stirring device comes back to the starting point at regular intervals of time, that is, a closed loop, like, should it matter what pattern of stirring you should follow? Now let's say that you replace the force F on both sides of the equation by the well-known mathematical equivalent of force itself, that is, mass into acceleration. This would mean that an increase of any quantity on one side would cause a corresponding increase on the other side. So, if you increase the mass m of the spoon, this will lead to an increase of the curl produced in the fluid on the other side of the equals to sign. Now, if you reduce the mass of the spoon, don't you think that you will have to overcompensate in the acceleration department to generate the same amount of curl? So, if you are stirring with a smaller stirrer, don't you think it will be better to increase the acceleration? Even better, why not let an electric motor do the heavy lifting, or should we say heavy stirring in this case? Now let's say the mass of the fluid is increased. That is, instead of thin, plain water or soup or coffee, you are dealing with highly viscous fluid like cement. Isn't it better to have a faster rotating stirring device? Or at least a bigger stirrer should help you somewhat. But nothing works as good as speed of the stirrer. So faster moving stirrer equals to more fluid stirred, and bigger stirrer equal to more fluid stirred. Now in the part 2 of this video, we will see how this equation works both ways. That is, stirring can cause curl and vice versa. That is, an already existing curl can move objects move in a loop with a certain force. Further in the next video, we shall see the application of Stokes Theorem in industrial and large-scale application. Also, does the Stokes Theorem apply to powders? Further, are there an astronomical application of the Stokes Theorem? Watch all this on the part 2 of this video at Visualizing Math and Physics. Remember, if it's there in equations, it's there in your life. For every equation has a story to tell you.
What if there was an e-book that explained major concepts of math using simple and everyday examples and analogies? What if sine theta is a measure of how much perpendicular two forces or objects or influences are with respect to each other? So a roof which is perpendicular to the flow of snow, won't it collect more snow than a roof that is less perpendicular? Now, coming to cos theta. Cos is a measure of how much parallel two forces or objects or influences are with respect to each other. Say two forces push a drum. Won't the maximum effect be when these forces are acting parallel to each other? Complex numbers. They come into math whenever one parent force or influence gets divided into two daughter influences. You can call one daughter influence as the real part and the other daughter force as the imaginary part. What if the base of logarithms is the rate at which change takes place? What if log of a number gives you the cause for every effect? In calculus, dx means keep adding along the x-axis. D means keep adding along the y-axis. Doesn't means keep adding along the z-axis. D theta means keep adding along a vertically curved plane. Deep psi means keep adding along a horizontally curved plane. DH means keep adding along increasing height. Doctor means keep adding along increasing radius. Also, what if integration and differentiation are reverse processes of each other? Add disks one above another along a height, you get a cylindrical structure. Thoughts integration. Remove disks along height, you get circles. Divergence is the rate of change of a quantity, for example heat, along the x, y and z axis simultaneously. What if curl is a measure of how much a field can make you spin? What if I, j and k in the formula indicate different planes of rotation? What if the diagonal of a matrix is the axis of rotation of a matrix? What if all these intuitive examples and understanding is explained in one single e-book? More such concepts explained intuitively. Link is given below in description.